This naturalrefrigerants.com article is being read by an automated voice. U.S. use of HFOs and HCFOs expected to more than double by 2030, warns EIA, by Christina Hayes. Published July 22, 2025. Consumption of hydrofluoroolefins, HFOs, and hydrochlorofluoroolefins, HCFOs, in the U.S. is projected to more than double by 2030, reaching approximately 106,000 metric tons, up from around 40,000 metric tons in 2021, according to a new report from the Environmental Investigation Agency, EIA. The report, Persistent Problems, raises concerns about the environmental and health impacts of these chemicals, which are often marketed as climate-friendly alternatives to HFCs and HCFCs. While HFOs and HCFOs have lower GWPs than their predecessors, the EIA warns that many are manufactured using ODS and HFCs as feedstocks, intermediates, or process agents, or produce these chemicals as byproducts. The illusion of HFO's sustainability is shattered by the emissions of climate and ozone-damaging gases associated with their production and use, explained Joanna Sparks, a climate campaigner at the EIA. Due to a lack of transparency in industrial reporting, the full climate and ozone impacts of these emissions remain difficult to quantify. However, the EIA notes that available data suggest the impacts could be substantial. Beyond greenhouse emissions, the report also highlights the growing concern over persistent pollution from per- and polyfluoroalkyl substances, PFAS, including trifluoroacetic acid, TFA, a byproduct of atmospheric degradation of HFOs. PFAS are linked to a range of environmental and health risks due to their persistence and mobility. It is clear that regardless of what the fluorochemical industry claims, HFOs pose unnecessary risks to people and to our environment, added Sparks. Production. Although detailed data on HFO production is limited, the EIA has reported that manufacturing has increased significantly since 2011. As of 2022, the U.S. Environmental Protection Agency, EPA, had identified 16 HFO or HCFO production facilities located in China, India, Japan, and the U.S. Despite being a major consumer of these substances, Europe does not appear to produce HFOs or HCFOs regionally. Instead, it primarily imports them from China, and the U.S. Globally, HFO 1234YF represents the bulk of HFO production. HFOs are typically patented by large chemical companies, and the number of HFO-related patents continues to rise, according to the EIA. Most production sites are operated by or in partnership with U.S. multinationals Arkema, Chemours, and Honeywell. Consumption. The use of HFOs is not currently regulated under the Montreal Protocol or its Kigali Amendment. Available data indicate that HFO use is increasing as more countries phase out HCFCs and phase down HFCs. To date, consumption has been concentrated in developed nations, particularly Japan, the U.S., and much of Europe, where phase-out and phase-down timelines are more advanced than developing nations. For example, roughly 26% of the EU's F-gas supply is HFOs or HCFOs. HFO 1234YF is the most widely used, especially in the mobile air conditioning sector, where it was in 97% of newly manufactured passenger vehicles in 2023. It is also commonly blended into refrigerant mixtures for use in commercial refrigeration and stationary air conditioning systems. Many national F-gas policies indirectly incentivize the adoption of HFOs rather than controlling them, the EIA finds. Emissions. Accurately measuring global HFO emissions is challenging due to the short atmospheric lifetimes of these substances. Compounding this, there is growing evidence that emissions from feedstocks and byproducts are frequently underreported or overlooked, contributing to significant gaps in emissions accounting. The breakdown of HFOs in the atmosphere can produce several products, including CO2, TFA, and in some cases, small amounts of HFC-23, which has a 100-year GWP of 14,700. While HFOs are only a partial contributor, total atmospheric breakdown of F-gases may release up to 215 metric tons of HFC-23 annually, a figure likely to rise as HFO use increases, the EIA noted. Once indirect emissions are taken into account, the GWP of HFOs can rise substantially. For example, the 100-year GWP of HFO 1234ZEE, a common replacement for HFC-134A, increases from 1 to approximately 20 when the formation of HFC23, a potent byproduct, is factored in. Managing TFA. Under the OECD definition, many HFOs are classified as PFAS. While degradation rates vary across different HFOs, the most widely used HFO 1234YF breaks down entirely into TFA with a 100% yield. As global production and use of HFOs increase, so will TFA concentrations in rainfall and surface waters. Projections suggest that combined emissions from HFC 134A and HFO 1234YF could result in 360,000 to 540,000 tons of TFA formation annually. Given the irreversible nature of TFA accumulation, environmental groups argue that regulatory action should proceed alongside continued scientific review. Quotable: time and time again, the fluorochemical industry has produced expensive, patented refrigerants, controlling the supply and with little transparency into their production and its impacts, said Christopher Douglas, a climate policy analyst at the EIA. The industry may be eager to flaunt its newest patented refrigerants, but the rest of us are tired of the bait and switch, being left to clean up the harms and costs of these chemicals only after they are ubiquitous in our lives.